This conference will now be recorded.
Good afternoon, everyone. I am Rachni Jain. On behalf of agricultureinformation.com, I'd like to welcome you all to this online. Please take a moment to review the guidelines for this online meeting posted in the chat window. I now request the moderator, Mr. Lakshmipati, to introduce the speaker and start the meeting. Thank you.
Thank you, Ms. Rajini. Good afternoon, everyone. I am Lakshmipati and I'll be moderating this meeting. Agricultureinformation.com likes to welcome to this meeting Mr. S. Vijayakumar, AGM of Technical Services, Premier Irrigation Agritech Private Limited, Bengaluru, Karnataka. Mr. Vijayakumar will be speaking on the topic micro irrigation, why it is absolutely necessary. I now request the speaker to begin.
Good afternoon to all present in the meeting, and thank you very much, sir, from the Agriculture Information for inviting me to this particular webinar, and I'm very grateful for the opportunity given. So I will start my presentation. So the topic is why do we need to have micro irrigation, or very commonly known as drip irrigation? What is the need? And this is the context behind which we are going to have the particular webinar. And I'm not able to move the slide. Slide is not moving. Yes. Okay. The topics that are going to be covered in this basic training program will be divided into 4 parts. First, I'll be talking about the importance of water. What is the definition of irrigation? What are the methods of irrigation? Second will be why micro drip irrigation? What is the advantages? What are the efficiencies? What are the various methods? What are the different products that can be used in this particular context? And I will take a small case study of a Budigere village farmer very close to Bangalore at a village at the Devanhalli Taluk. So this will be the flow of the program. So coming to the first part is the importance of water. So we are all aware water is the most important commodity on the earth, but we don't pay much attention to it. So when you look at the distribution of water on the surface of the earth, we find 97.5%, close to 98% is salt water, of which only 2.5% is the fresh water. And in this 2.5%, when you again further break it down, you will find almost 69.5%, that is close to 2% on the whole, will be actually frozen in the glaciers like the Himalayan or the ice caps, which is again not available for either for drinking purpose or for irrigation purpose. So what is really available is basically only 1%. So this is what is really available. So therefore, it becomes very important that we have to save water to save ourselves. So this is the message from this particular slide is to show that how much little water we have. We have a lot of salt water, but can they be used? They cannot be used. We have to desalinate it. It is a very costly process. So that is what we are trying to tell, that the available water is very, very minuscule. So what is the challenge now that is there in the water availability? So as you can see from the map of India, when we come to the Indian context, we will find 54% of India faces very high to extreme high water stress. And you can note down the various baseline water stress. This is the sources from the Water Resources Institute. You will find that many states are in the extremely high category or extremely high rate of water extraction. What do you mean over here is the withdrawal of water either by tube well, bore well, or any other way, either for drinking water or for irrigation. And when we look at the water consumer, who is the major consumer of this 1% water? So you will find that irrigation, this is the statistics from the Central Water Resources Commission, 85% or 85.3% is actually going into the irrigation sector. So again, we see that the pressing demand that is there for the irrigation part. So what is the need of the hour? So I will go back in time and tell you a small thing, how this whole thing happened. In the year 2003, under the chairmanship of then Chief Minister of Andhra Pradesh, Chandrababu Naidu Garu, a task force committee was set up to have a vision 2020, and the need of the hour, it was thought that we should have a smart use of water, which is now very fondly called as the Pradhan Mantri Krishi Sinchai Yojana. So here basically the objectives are, we'll have to use the available water, which has to be used very smartly. And as you know, on one side the population is increasing, and by the year 2030 India's population will overtake China. So the increasing need for food will also be very high, and the availability of the water also is coming down. So these are contrasting situations. And from the same given piece of land, I will have to increase my agriculture in, I'll have to give inputs, and I have to have also the problem of power and the labor, which all of us know. So the government of India, under this scheme, decided that unless we use this water very carefully, and for that the scope of micro irrigation. So micro irrigation is a very broad term which broadly covers drip and sprinkler irrigation. So this is the context of the whole, the need of the hour that is there today. So now I will take you through what is the simple definition of irrigation. So all of us are aware how the water is lost, how water is lost from the plant. So there are two basic processes which we have all learned in the 8th standard or 7th standard in our biology, that water is lost by two basic processes. One is the transpiration. Where does the transpiration happen? It happens from the leaves of the plant. So you know there are small openings called stomata under the leaves of the plant. So the water is actually going out. So on a sunny day, the water is getting transpired, and surrounding the plant, the soil, there is evaporation from the soil. Both these put together is classically called as evapotranspiration. So basically some amount of water is going out from the, or a major amount is going from the leaves, and water is lost from the soil. Put together is called evapotranspiration. Now this is basically the water that is going out. So now the question comes, where do I give the water? Do I irrigate the soil, or do I irrigate the roots? The answer is of course obvious, that we have to irrigate the roots. So that is where the whole context of creating a water balance in a country like maybe UK, where you have rainfall for 10 months in a year, rainfall will take care of the irrigation needs. But in a country like India, where we have this rainfall which is there only in the two prominent monsoons, so we have a very short gap of 50-55 days or 60 days, within which of course there are exceptional years, and we will find that we have to maintain this balance. So basically irrigation, we have to take care of the needs of the, so whatever water is going out has to be given back to the plant. The plant cannot talk, so we have other indirect methods of finding out how much water is actually required by the plant. So now getting into the next part, let us see what are the various irrigation methods and why we should adopt this micro or drip irrigation. So looking at there are many types of irrigation, but I am going to cover the main 5 which is very popular across the globe. Of course, I have left out pivot irrigation because it is not relevant to India as of now, except in a few places. So the first most commonly adopted method is the flood or the surface irrigation, followed by the sprinkler irrigation, and then we have the rain gun irrigation, and then we have other small devices called micro sprinklers or spray jets, and finally we have what is called as drip or trickle irrigation. And this drip irrigation can either be laid on the surface, or it can be laid below the soil, 4 to 6 inches depending on the active root zone. So let us look at flood irrigation. So the picture is very clear. Now there is a plant in the first one, you are ponding the water around it. It is the common notion of anyone to think that actually that the water has to be ponded around the plant. So here what is happening? Here the water is getting fully filled up in the basin, and you know that the roots are very also have to breathe. So if you're going to fill up the entire area with water, so the water is actually ponded. So actually you are giving it excess water. It's like a human being being asked to have an entire week's food in one day. So even here, when you look at the sugarcane field, you will find the entire area, the water is being flooded. So what is happening over here? You are wasting a lot of water by making it to go through all these channels, by waterlogging, by deep percolation. And what are the problems associated with this? First you are wasting water, and then you are always keeping the plant, you think that the plant is getting a lot of water, but actually it is not getting a lot of water unless it comes to a state where the air and water space is balanced, it will not be able to take the water. And this also is going to add a lot of weed growth. So you will find that when you do flood irrigation, you are also giving water to the unwanted plants. Next is the sprinkler irrigation. So this is a very important method of irrigation which is popular world over. So if you ask me which is the number one method of irrigation in the world, even today it is surface irrigation or gated methods are there. Second comes the sprinkler irrigation. In this context, the sprinkler irrigation actually you have sprinklers which are spaced at a certain distance apart. The concept is that you are going to have one sprinkler's water falling onto the head of the other sprinkler. So there will be an overlap. So this is what we are trying to do. And the spacing between the sprinklers generally is between 40 to 60 feet. So as you can see from the sprinkler, there are two nozzles. One nozzle which is throwing onto the far end and one nozzle which is throwing around the sprinkler. So this method of throwing water for closely spaced crops has found to be very efficient. In this context, the company from where I come from, Premier Irrigation, we started this sprinkler irrigation way back in 1965, and we were the first company to introduce sprinklers for coffee and tea. So because there a specific type of irrigation is required, and the sprinkler is able to create what is nothing but a natural rainfall. So this is the basic thing of a sprinkler irrigation. Please note the efficiency, it is between 70 to 75%. 20-25%, as you can see in the in-between spaces, and due to wind effect, there is some loss that is happening. Coming to the third method, you have a rain gun. A rain gun is nothing but a big sprinkler. It's also called as a large volume sprinkler, and it is able to throw a distance of between 80 to 120 feet. So depending on the pressure that is available. So if you ask me how much is the pressure required, it depends upon the availability of the water and the horsepower of the pump over there. So basically you can see the sprinkler is almost covering an entire area, and it could cover anywhere between 0.75 to 1 acre at a time. And the efficiency of this particular system is designed well. You can see it is almost throwing in the form of a rain, and it is also between 70 to 80%. They are also typically large diameter sprinklers, and you can have it the radius varying from 80 to 120 feet. Coming to the next method, that is the micro sprinkler and the spray jet. So this is a very popular, like now you see as I am going, now the sprinkler has got a radius of around 10 to 15 feet. So it is very popular in nurseries, it's very popular for cardamom, and these for vegetables, and also another big advantage of using the micro sprinklers, which is there, is that it has got a very high efficiency of 80 to 85%. In addition to irrigation, it can create what is called as a microclimate. Microclimate means that you are going to have a suitable temperature. For example, if it is a very hot day, we can use these micro sprinklers not only for irrigation, it can also bring down the temperature. And it is very good for germination. There are many crops like potato, onion and all that, where vegetables, where micro sprinklers are widely used by our farmers. And finally, we come to drip or triple irrigation or trickle irrigation. As you can see here, there is a tube that is going in between the rows of the vegetables or whatever crop or flowers, whatever is there. And when the tube is laid on the surface, when the drip tubing is laid on the surface, it is called as a surface drip irrigation. The efficiency, as you can see, you are watering exactly where the water is required. You're going to give this water right at the root zone. So the efficiency is between 90 to 95%. And today the latest in drip irrigation is to take this tube below the surface of the soil, anywhere between 4 to 6 inches. And when we do that, even that small evaporation loss that is there on the top, that is also conserved, and the efficiency can be as high as 95 to 98%. It's like telling that I'm giving an intravenous drip for a patient. So directly the glucose is injected into the system. So that way, these are all the. So now you may be wondering, what is this? He's going on talking of efficiencies, methods. So let us summarize what we have learned till now. So we saw that the flood irrigation, 30 to 35% is the efficiency. That means for every 100 liters of water that you are going to supply, only 35 liters has been used. Balance has got wasted. When we take the sprinkler, for every 100 liters, 70 to 80 liters have actually got utilized by the plant for its needs, for its metabolic needs. And rain gun is also between 70 to 80%. And micro sprinkler is between 80 to 85%. And drip irrigation, you take it is around 90 to 95%. So what do we understand from this? Like just looking at numbers will not help. So let us do a small math. Let us take the drip irrigation efficiency is 90%, and we know we will compare it with flood. So 90 divided by 30 will be how much? 3. That means if the water that is available for 1 acre of flood can be used for 3 acres of drip. Let us do one more number calculation. Let us take sprinkler. It's 70 by 35. It will be 2. That means the water which is available for 1 acre flood, the same water can cover an area of 2 acres. So this is the understanding of the efficiency, and how when we say if I have very little water, then I will be able to irrigate a much larger area. So this is the context of the efficiencies. Now what is drip irrigation? So to tell you that drip irrigation is a very precise method to apply water, fertilizer and pesticides slowly, frequently and directly to the root zone of the crop. Please note the words, you have to apply it slowly, frequently and directly to the root zone of the crop. So basically when we look at the classification, we have two basic types of irrigation system based on the spacing of the uh, crops that is there in picture. So the first one is the inline drip irrigation system, which is very common for the close space crops. Whenever the spacing is very close, like sugarcane or vegetable or turmeric or cotton or maize or banana, papaya, you name, even today rice and wheat, on all these crops where the row spacing is very close, we go for what is called as an inline. Inline drip irrigation means there will be a tube, the dripper is co-extruded and manufactured, and the dripper is there inside the tubing. So this is called an inline drip irrigation system. We have two varieties. You have the cylindrical type and we have the flat type of emitters. There are two types of emitters. Now when we come to the online drip irrigation system, as the name suggests, online, you will have this tube, and from the tube you will take an extension, and then you are going to fit the drippers around the root volume of the crop. So this is generally preferred for the wide space crop. You can understand, if I'm going to use the inline for a wide space crop like coconut, which is say 25 feet by 25 feet, I am going to water the in-between area unnecessarily, unless I have an intercrop. If I am having an intercrop of vegetable, then it is okay. But if I'm not having an intercrop, then I'm going to be wasting the water. So here I will be giving a point source irrigation, which is called as an online drip irrigation, which is very common for coconut, arecanut, mango, citrus, pomegranate. But today in the modern advantage of having an inline drip irrigation system, we can also go for 2 lines of inline for a wide scale. Like today, like if you go for citrus, certain crops, we are having 2 lines of inline. That is slowly replacing this particular thing, because the installation part is very convenient. You just have to have the pipeline, and you can directly drill and have your drip line over there for every row. So here you will have to drill, put this tube, and then punch the drippers wherever you require. So this is what is the difference between the inline. So inline means the dripper will be a part of the tubing. Online means you will be having the tubing and you will put the emitters. Typically anywhere between 3 to 4 emitters are provided. Now what are the benefits of drip irrigation? So if you look at the benefits, first will be the water saving, second will be the fertilizer saving, third will be the increase in yield, and then the reduction in weed growth, and then we have the major power saving and infrastructure, which is nothing but our manpower saving. So let us look at these by means of simple photographs. So this is the water saving. So it has been proved world over, and India particularly, we are the leading country as far as adoption of micro irrigation after Israel. So you will find the water saving is anywhere between 50 to 90%. And you will also note that if you want to take the best advantage of a drip irrigation or a micro irrigation system, you will have to apply the water soluble fertilizers also through the drip system. So by doing so, in the conventional method of broadcasting the fertilizer, which you are going to throw even to the weeds or to the adjoining area where it is not required, so water and fertilizer and even pesticides can be directly applied, and the quantum of fertilizer that needs to be applied can be reduced, because in broadcasting there is going to be a wastage, and therefore you are going to increase your quantity by some X percentage. So it has been proved that around 15 to 35% of fertilizer saving also happens. Coming to the yield, this is, like I told you, the challenges of water depletion and increase in population. We have no choice. For example, your father or grandfather must have had 10 acres. then his sons have made it 5 acres, and further it has become 2 acres. So the land size is going on diminishing. So from the same area I have to increase my productivity. So here drip irrigation or micro irrigation is a boon. So it has seen that anywhere from 30 to 60% in open condition you are going to get the advantage, and the weed growth will be definitely very much minimum. You can see the water is being applied. So in a crop like sugarcane, if you are going to do flood irrigation, you may get a yield of say 30 to 35 tons per acre. Whereas if you are going to do drip irrigation with fertigation, yields as high as 70 to 80% also have been observed. Another two advantages of drip irrigation is that it is not affected by wind. We all know sprinklers have one disadvantage, is that when the sprinkler rotates and if there is a heavy wind condition, the wind will push the water flow towards one side, but that is not there because the lines are in the bottom, so there is no problem. And this is one advantage which not many people are aware, that drip irrigation can be used with saline and recycled water and even for saline soil. In fact, it will make your saline soil better. And if you recycle the water, for example, the Bangalore airport, if you go to the airport and see the entire lawn and the area that is there, the entire water that is being used is actually recycled water, and the water is being given through the drip line. So this is another big advantage, and what white lines that you are seeing is actually the salts getting leached out to the side. So this is another advantage with drip irrigation. So these are some of the bigger advantages. And finally, when you go for the type, whether you have a flat land or whether you have a sloping land or whether you have an undulated land, any land condition is not a challenge for drip irrigation. If you have to do flood irrigation, you have to terrace it. You have to take the water to the highest part and then allow the water to flow down by gravity. That issue is not there because you are going to have a pumping system, and from the pumping system the entire water will flow as it is required. So that is another plus of the drip irrigation. Okay, so till now we saw what is the importance of water, what are the advantages of drip irrigation. Now let us look at a typical drip irrigation system. A typical drip irrigation system has got three main parts. The first part, which is very close to the pump or the water source, is called as the head control system, or very commonly called as the filter station. So there are a number of components over here which I will explain to you as I go along. After that, the water, because you know these the drip irrigation outlets have very small nozzles, so when the water comes out, it has to be filtered. Otherwise, the particles that are present in the water, whether it be sand or whether it be any organic impurity like algae, that will come and block the drip system. So therefore, filtration becomes a very important part. So filtration basically is the heart of the system, and from there the water is actually getting into the that is the main line and the sub main line. So that is actually called as the water carrying system. So the water from the filtration is getting carried into the main and sub main line system, and from the sub main line system it is getting distributed into the tubing. So here basically the water is pumped, passes through a filter, then you have a main and a sub main line, and from this sub main line you have these lateral lines which are made of LLDP or linear low density polyethylene, and from the lateral lines the emitters are actually fixed to the root zone. So you can see how the entire system is getting water. So this is just one small representation. So how does it actually look in the field? Like I've given you a schematic. So what are the components which has been laid down by the government of India? You will notice that this is the borewell, and from the borewell the water is passing through a number of components. You have first a non-return valve. What is a non-return valve? When you are pumping out this borewell water, and since you are going to apply the water soluble fertilizer through the drip irrigation system, as you're seeing through this bucket, we would never want this fertilizer water to get back into the borewell. So therefore we have to have a valve which will prevent the backflow. So a non-return valve will allow the water to flow only in the forward direction and not in the reverse direction. So that is the first safety device. It also has, after which you have what is called as an air release valve. So when the pump has not started, then what happens? Actually, there is air in the pipeline. That air has to come out. For that air to come out, you need an outlet, and that is provided by this air release valve. So only after the air gets released, then will the water enter into the pipeline system. Next, what you see is a bypass assembly. Now you may be asking, what is the need for a bypass? So whenever you have excess water in your system, or you have a excess horsepower in your system, you don't want that excess water to get into the system, because it could go and increase the pressure and damage some of the components. So therefore we provide what is called as a bypass. This is a safety device, and also it has another advantage. By chance, if the farmer in the field forgets to, he closes all the valves and he switches on the motor, and if you have kept the bypass assembly on, then what will happen? The water will keep circulating and it will prevent your motor from burning out, or your submersible pump from burning out. And then what you are seeing is the venturi injector. The venturi injector basically is provided to apply the water soluble fertilizers to the system. So this is for the venturi to operate, you have to create a difference in pressure between the inlet and the outlet, for which we have this throttle valve arrangement. So in the normal condition, this valve is fully open, and when you throttle it, when you close it a little bit, say 20 to 30%, what will happen? A part of the water which is there in the main line will get actually, which will actually go in, which will get sucked into this. So by the principle of suction, this venturi is going to work. And then after that, and finally, since we say water soluble fertilizers or pesticides, whatever we may apply, they may not be 100% water soluble. Therefore, if there are any leftover impurities, it has to be passed through a basic screen or mesh filter. So this is the basic head control unit for a typical farm. So now let us look at the components that are there actually. So non-return valve, it's a very simple valve. Actually, what is it? The function, as I told you, is to prevent the backflow of the water soluble fertilizer back into the water source, number one. And if the plot is at a higher elevation and you have your borewell or your open well at a lower location, what will happen when you switch off the pump? The entire water will rush back, and this water that rushes back actually goes and creates pressure onto the impeller of the pump. So the impeller of the pump is going to get damaged in the long run. So therefore, providing a non-return valve, it will prevent the back pressure from damaging the pump impellers after shutdown. So it's a very simple thing. It's just a one-way arrangement of the movement of this ball which is there inside. Next is the air release or the vacuum release valve. So this, which you saw as the second safety device that is there. So first function would be to release the air from the pipeline, because when you switch on the motor, the air has to first come out. Even in your house, you would have noticed on top of your tank, you have two pipes. You have a stand pipe which has got one to release the air. Only when the air release, you are going to have water getting into the system. You would have noticed that when you clean the tank, invariably, for the water to start in your tap again, it will take some time, because the air would have got locked. So that air locking has to get cleared. So therefore, a air release or a vacuum release valve releases the air during the pump startup. It has got another important function. When you shut off the system, what will happen? The difference in pressure between the outside and the inside of the pipe is going to be different. So there is going to be a negative pressure inside. So that means you are going to create a vacuum. So in order to break the vacuum, this is going to, so basically there is a ball which moves up and down. So first this ball would be in the bottom position. When the water starts filling up, this will go and lock up. And once it is full, then it is going to, all the air has got released, it will be closed. And then when you shut off, automatically this ball is going to come down, and it will allow the outside air to come inside, and the balance of pressure between the outside and the inside will automatically take place. And also we provide this air release cum vacuum breaker valves in case of subsurface drip irrigation, because when we have a drip irrigation, subsurface drip irrigation, the drip line is actually going inside the soil. So therefore, when the system is switched off, there is a possibility of the mud and other particles entering into the drip line in a subsurface. So in order that does not happen, we will be providing this extra air release cum vacuum breaker valves also. Now for the control of the system, to create the difference in pressure for the venturi to operate and to set the required pressure, every system, whether it is a sprinkler system or a drip system requires a certain pressure, like it is a 1.5 kg pressure that is required at the starting. If that pressure is there, to set that pressure, you need a valve. So this basically, this throttle valve has two functions. It will create the difference in pressure for the venturi to operate, and also to set the required pressure that is required for the operation of the system. And the third is the venturi. The venturi which you have seen, this is the whole system. We give it as a manifold arrangement, and here we are creating the difference in pressure. So as you can see, when we throttle it, you are going to have a difference in pressure. So typically we have two sizes of venturi. One is the 1-inch venturi and also the 2-inch venturi. The function of the venturi basically is to inject the water soluble in the fertilizers into the drip system. And also, as you know, we are providing filters and everything, but ultimately there is a dissolved salt that is there in the water. So that will tend to go and clog the emitters. So periodic maintenance of the drip system will be required, for which we do what is called as an acid injection. A mild acid, preferably a hydrochloric acid or a phosphoric acid, will be injected. And to inject that acid also, we will require this venturi. So now you have seen all the head control units, and then we will come now into the basic drip line. So basically, after the water has passed the filtration, the water is coming into the drip line. So the drip line, this is the inline drip irrigation system, which I told you, which is very commonly used for the vegetables and other close space crops. So here, as you can see from the photograph, you will find that the dripper is co-extruded along with the pipeline. And you can see the water is entering through the slits, getting into a labyrinth. The flow is regulated and the required quantum of water will be coming out. So you have this available in various sizes like 12 millimeters, 16 millimeters, various wall thicknesses like class 1, class 2, and different diameters, even 20 mm is also available. One very important feature of this product from Premier is that there are 4 holes in the emitter outlet. So you might be wondering why we have given 4 holes. So you know that there is going to be clogging by salt. So even if 3 holes are clogged, even 2 or more holes are clogged, still the water will come out an exact quantity of water. So for example, if it is a 2 liter per hour dripper, still the water will come out from the 4th outlet correctly. So you may be wondering how that is happening. So here the water is getting filtered, getting into the labyrinth, and when it comes out, it is coming out in this circular area. So if the outlets that are there, there are 2 here and there are 2 here. So even if 1, 2, 3 are closed, still one will be open. But because it's a circular area, you can understand that the blockage happens in this area at the outlet. So therefore, you are going to have very less chances of clogging. I'm not telling that we have to maintain the drip system, but then you can, if suppose the farmer has not maintained it, but we still have this USP of having 4 outlets in the emitter. So this is one thing of one type of inline drip irrigation system, which is called drip in, and it is cylindrical in shape. And this is basically a graph. What I want you to understand from this graph, so if you look at the y-axis, this is basically what is shown over here is the discharge, and the x-axis is the discharge rate of the emitter. So here I want you to understand this dripper can work at a wide operating range. For example, half a kg pressure right up to 2 kg pressure. What is the implication of this? For example, in a borewell, you know that during the summer the water levels will drop and the pressure will also come down. Even in such a condition, our dripper will be able to give you water. Even at a half a kg pressure, it will still be able to give you about 3 liters. And if after the rains, if the water is going to be higher, the pressure is going to be higher, we'll still get a higher. Then you may ask, how do I control the discharge? What I will do is I will play around with time. So I will increase my irrigation time duration during the summer, and during the rainy months I will actually cut it down. When it is fully raining, of course it's not required. So this is the similar graph that is there. So basically it's operating over a wide pressure range. This is the graph for a 4 LPH emitter, and this is a graph for a 2 LPH. So basically 2 liters per hour, that is the discharge of this emitter, and this is 4 liters per hour. And whenever we talk with respect to a particular pressure. So at a 0.7 kPa, that is 70 kPa, or 0.7 bar, or 7.7 kg per square centimeters, it will give you a discharge of 4 liters per hour. So that is why it is called a 4 liter, but it has got a very wide operating range. And similarly for the 2 liter, it is 1.92. The second, similarly, we will see that there are drippers. Again, we have what is called as we have the drippers which are smaller in shape. This is again an inline drip irrigation system where you have 2 outlets, and instead of 1 we have 2 outlets. And here also again we can give you in 2 liters and 4 liters. Again here the dripper is co-extruded as a part of the system, and the waters will start trickling out. So we can give you very cost effective from a low wall thickness to a high wall thickness. We have products which will last for 2 seasons, for 3 seasons, for 5 seasons, and as per the government of India, which it has to last for minimum 5 years. So all these particular varieties of products are available. So basically the tubing thickness will vary, And here you can see how the water is entering through a wide labyrinth or a filter area, and then it gets into the labyrinth, the water flow gets regulated, and the water starts coming out in the form of a droplet. So this is the second type that is there in the inline drip irrigation tubing. And again, this is the graph, just the same graph. Like you will always know, you have a wide range of operating pressure. So even in the low summer condition and the high rainy condition, you still have the dripper able to function, and you can see the performance characteristics. It's very similar to what I told you about the other product. Now, when we come to the white space crops, which I was telling you, where I was talking about the online drip irrigation system. So this is a photograph of a dragon fruit cultivation, and you are see how the drip line is going, and the drip line is put in the form of a loop, and around this loop at the 4 points, because there are 4 dragon fruit cactus which are climbing up this support. So at four different points, you can give 4 emitters. So this is called online. The dripper is actually punched online. So that's why it's called a online drip irrigation system. So again, here also you can notice that typically for a drip irrigation system, the recommended pressure at the inlet of the emitter is around 1 kg or 1 bar. And this particular product will give you around the tab emitter or take apart button emitter gives you around 4 liters. So this photograph is the courtesy of from the newspaper of the dragon fruit cultivation by Hindu. I thank them for this photograph. And now when we look at the filtration, so now we have seen the tubing, and now I'm getting a little more detailed into the types of filters. So you know that we have different types of water sources. So we have a bore well, we have an open well, we have a lake, we have a reservoir. So based on the water quality and water condition, and we have different horsepowers of the pump, starting from a very small 1 horsepower, which is giving about say 5,000-6,000 liters, or and going up to a very big pump which is giving 40,000 liters. So we have different filters. So they are broadly classified into a mesh filter, which you are seeing in the first photograph, and then the disc filter, and then the gravel filter, and finally the hydrocyclone filter. Now let us get into the detail of this. So the mesh filter is the most basic filter which is there, and this is basically a 2-dimensional filter. So what is there inside? You have a plastic cartridge, and the water is getting filtered. So water enters, gets filtered on the surface. This is actually a PVC or a plastic engineering plastic cartridge on which you have a stainless steel mesh. So this is very simple to clean. All you need to take is to rinse out this particular mesh in a bucket of water, and it is available in various capacities starting from a 10 meter cube. 1 meter cube is actually 1000 liters per hour. Sorry, 10,000 liters per hour. That means you can filter in 1 hour. This filter can filter about 10,000 liters. So depending on the outlet that is available at your pump, whether it is a 2-inch outlet or a 2.5-inch outlet or a 3-inch outlet, various sizes are available. This is recommended for generally for a borewell which has got very minimum silt, and typically for an online drip irrigation system. The second more advanced category of a filter is a disc filter. Here actually instead of a steel cartridge, you have what is called as a disc. So the disc is nothing but a ring type of a structure which has got grooves on it, and there, for example, here typically there are about 300 such rings, one sitting over the other, and in between the grooves the helix is there, and the water is getting filtered on the surface as well as it is getting through the depth. So that is how the filtration is happening. So this is basically a superior filter and slightly expensive, and this is generally recommended for the inline drip irrigation system. As you know, in the inline drip irrigation system, the inline emitters are there inside the tube, and that cannot be removed and cleaned. So therefore utmost care should be taken to give a good filter. Then comes the sand filter. So whenever you have an open water source, you have another challenge. You have the challenge of algae, you have challenge of organic impurities. So here basically you have a sand filter is nothing but a media filter, where basically inside you will have silica sand, and the water will pass through this filter, and after that you are going to give a basic filter. So basically when you want the filter to operate, I will just open the valve number 1 and valve number 3 and shut off valve number 4 and valve number 2, and the water will go through the silica. The silica is nothing but a sharp edged silica which will be able to make the organic impurities get stuck in between the layers of the silica, and then after that it will pass through a screen filter. So this is the basic operation, and when after some time what will happen, the silica will start, sorry, the algae will start getting collected on the top. That has to be cleaned, I will just reverse the water operation. What I will do, I will make the water, I will close valve 1 and valve 3, and I will make the water to flow from bottom to top and allow all the algae to come out. Keep in mind this valve number 4 should be partially open. You don't keep it fully open, otherwise the entire silica media also will come out. So basically this is a sand filter which is used to remove the algae and organic impurities, and this is never given independently. After this you have to provide either a screen filter or you have to provide a sand filter. Then now we have another challenge that everywhere the depth of the borewell is going deeper and deeper, and you will find lot of silt is coming in, and if I provide a basic filter, it will get blocked in some 15-20 minutes. So what do I do in such case? In such a case, when you have very heavy silt loading, we have another filter called hydrocyclone filter. As the name says, hydro is water and cyclone is you are creating a vortex. So basically the water, this is also a pre-filter. The water from the borewell is directly entering and it is made to go in the form of a spiral. So basically it's like a wash basin effect. All the particles will get collected at the bottom and the clear water will come out. So this is actually a very useful filter, particularly in the cases of a deepening of borewells. But one thing is you have to note that if these particles have to come down, the specific gravity of the particles have to be more than 1. You will find in some borewells you're getting very fine mica which actually float on water. For that, this hydrocyclone filter will not work, in which case you will actually have to go for a sand filter. So these are the two challenging situations that actually the farmer is forced to face. So this chart actually I have summarized the entire water source. What is the water source? What is the type of impurity? For example, the borewell, if it has got silt and minimum silt and sand particles, I will go either for a screen filter for an online drip irrigation system, or I will go for a disc filter for an inline drip irrigation system. If it is a deep borewell where you have a lot of silt coming in, or from a river source if you are taking, then I will first give the hydrocyclone filter and back it up with a mesh filter or back it up with a disc filter, depending on whether it is an online or an inline. And if you have a open water source like a river or a pond or a lake or a stream where you have algae and organic matter, then I will go for a combination of sand filter followed by the disc filter. And if you have again more silt particle also coming, then I will have the triple filter. I will have first I will have the hydrocyclone, I will follow it up with a sand filter, and then I will have the mesh or the disc filter. So this chart actually summarizes this thing. Why we are emphasizing so much on the filtration is the filtration is like the heart of the human being. If you don't take adequate care over here, the life of the system will be drastically reduced. So utmost care must be taken in the selection of the filtration system based on the quality of the water that is available. Then coming to the venturi, I'm getting a little deeper into the venturi part. The venturi, as you know, has got two main purposes. One is the fertigation. The water soluble fertilizer has to be applied into the drip system to get the best efficiency, because not only water has to be applied uniformly, we need even the fertilizers to be applied uniformly. So you have both the 1 inch and the 2 inch, different capacities basically. And just to give you a little bit, where should I use a 1 inch or a 2 inch? Before that, I will just explain to you how the venturi works. So venturi, if people know about the Bernoulli's principle, you will note that if there is a pressure difference between the inlet and the outlet, then what will happen? The pressure difference. So basically inside the venturi, if you look at the construction, you have a larger inlet and you have a constricted portion over here through which the fertilizer is getting injected. How is that happening? Because of suction. So you can imagine I'm having a glass of juice and I would like to drink it. I can either drink it directly or I can put a straw and then suck it. So exactly in the same way, by the suctional pressure, this fertilizer is going to get injected into the drip system. And this is available in 1 inch and 2 inch size, and generally 1 inch will inject anywhere between 150 to 270 liters. So let us look at it from the farmer's viewpoint. If I have a 100-liter drum, within about half an hour I can inject the entire fertilizer. If I have a 2-inch venturi, that will get injected in 15 minutes. So where do I use a 1-inch venturi? I can use a 1-inch venturi for small farms, and always it is good to inject the fertilizer also slowly. 2-inch venturi is generally preferred in a farm which is quite big. I need a large area to be covered, or the area of my irrigated area is long. There I can go for a venturi. One biggest advantage of a venturi is that the concentration of the fertilizer master tank that you make, whatever you make the concentration from the starting till the end, the fertilizer injection is going to be same. But it has got one drawback, that whenever you put an obstruction like this, there is going to be a head loss. Of course, these days we have made an improvement in the cross section or the design of the venturi, and these things are very beautifully designed. So even the head loss is actually taken care of. Now it used to be around 7-8 meters, now it has come to 4 meters. So the design has been suitably modified. So this is no longer the disadvantage has been covered up. So now, after looking at all the major components, I want to take up the case study from a farmer in Budigere, Devanalli, which is not very far away from here. And Budigere comes in Bangalore rural district. Okay, what was the problem over there? This is, I'm talking when I joined this line the way back in 1992. The farmer had 6 acres of land and he had drilled 2 borewells. One borewell failed after drilling. There was no water. And to his bad luck, the second borewell, he could get only 300 gallons of water, which is roughly around 1362 liters. 1 gallon is nothing but 4.5 liters. And how the water was coming? It was an intermittent supply. I will get water for 2 hours, then I will have a gap for 1 hour, and then overall I will not get water for more than 12 hours. And another problem that he had was the power was available. The Pakka 3-phase was available only in the night. And he had used a compressor motor because the water was not coming continuously. It will come in spurts. So that means if I look at the water that was available to him for 12 hours at 1362 liters per hour is only 16,344 liters per day. But he had a big ambitious plan. What was his plan? He had a 6-acre land and he said, I want to do 3 acres of coconut, around 145 plants at a 30 feet by 30 feet spacing, with guava as an intercrop, 15 feet by 15, around 435 plants. And the other 3 acres I will have banana, around 3,600 plants. So I just did the math. When you do the math, for example, assuming that the lowest water requirement or just coconut tree requires around 60 liters and a guava plant requires around 30 liters and a banana plant requires around 15 to 20 liters. If you look at the whole calculation, the total water required works out to 79,350 liters per day. Even if I pump 12 hours, I'm going to get only 16,345 liters. So what do we do, or what did the farmer do? So this is actually the plot which I'm talking about. This is, I'm not giving the details. Basically, this was a 6-acre plot and my project was done over here. This was the borewell. This borewell is working, which had only 300 gallons. And this borewell failed actually. And this portion of the area, he wanted to plant it with banana. And this portion of the plant, he wanted to have coconut with guava as intercrop. So what did he do? What he did was he constructed a small tank of 50,000 liters over here in the center of the plot and pumped all this water into this tank for 3 days. 3 days before itself you started. You know you're getting around 13,000 liters. So you pump for 3 to 4 days, store it. And from here, from this centralized tank, you adopt a drip irrigation system and you are able to drip irrigate the entire drip irrigation in about 6 hours. So another pump was used from here and the entire area was irrigated. So this was the solution that was provided to the farmer. I'm talking to you about a case in 1992. Of course, most of the farmers are available of it. What they do, you have a number of borewells, you have a centralized system, and if 1 or 2 borewells, 3 or 4 borewells are there, it is all dumped into one centralized area, and which is also called as a Krishi Honda. And from there, you put in another pump and then you do the drip irrigation for the entire area. So this is how the farmer at that point of time went in for drip irrigation way back in 1992 and was able to irrigate with a very small quantity of water of 300 gallons per hour. He could cover 6 acres. So this was the success that we saw, and most of the farmers understand this reality now, and drip irrigation has caught on very well, and particularly Karnataka is one of the leading states, and more than 12-13% of the area that is there is already covered under drip and further going on. Now, one small point I wanted to tell you, whenever we have this dripper selection, we have to take a lot of care on the type of the soil that is going to be there. You must understand how the water moves in the soil. In case of a sandy soil, as you can see, the movement of the water, because there is a lot of pore spaces, the water will directly go down. The vertical movement will be greater than the horizontal movement. So this water that is spreading will not be more than 1.5 to 2 feet. Whereas in case of a medium soil, like a loamy soil or a red soil, you will have both horizontal as well as vertical movement, and the spread is anywhere between 2.5 to 3 feet. And if it is a black cotton or a clay soil, the spread can be anywhere between 3 to 3.5 feet. So basically, depending upon the type of the soil, we have to select the emitter spacing of the inline. This is a very important aspect which I want all our farmers to take care. Whenever you have a sandy soil, please go for a 30 or 40 emitter spacing. The spacing between the emitter, between one emitter, should be 30 to 40 centimeters. If it is a loamy soil, you can slightly have it wide apart because of this bulb. So this will be between 40 and 50 centimeters between the drippers. And for a clay soil, you can have it even between 50 to 60 centimeters. All these different are factory manufactured by our company, and we will be able to give you at whatever spacing. So these are the standard spacings that are adopted. After the survey, we are able to. So basically, this subject of water management, you will have to, soil science is a very important part which you should not neglect. So this I'm just showing how the drip line is actually laid out in the field. So here the row, this is actually a plot where this was a sugarcane field actually, and the row to row spacing is 1.2 meters, and the emitters are actually between the emitters it is 40 to 50 centimeters. So this was, you can make out from the type of the soil. So basically the things were put, and when the drip irrigation works, the entire area will get irrigated over here. So whether it is vegetable or any other crop. So this inline drip irrigation. So the tube has already got the drippers which are already fitted into it. So this is how the laying of the inline lateral happens. It's very simple. The installation is anyone can, just 2 people can do it. In addition to the micro irrigation, we also manufacture sprinklers, which I told you. Sprinklers have got some peculiar advantages. In addition to creating artificial rain and cleaning of the leaves and climatic, local microclimatic control, it also is very useful in germination. You know, like drip irrigation has got a drawback that germination will not be that quick if the plants are very close by. So therefore, sprinkler irrigation, it's a common practice even in countries like Israel. The initial part, they will use a sprinkler, portable sprinkler system, and follow it up with a drip irrigation system. So sprinklers actually, like these are basically 2 models. One is the metal model and one is the plastic model, engineering plastic, and different specifications are there. I am not getting into it. So basically they will, after every 2 pipes, you are going to fit one sprinkler. So that is basically what you have to remember. Every 40 feet, you know that a standard pipe comes in a standard length of 6 meters or 20 feet. So after every 2 pipes, we will give a sprinkler. You have the water of one sprinkler head should hit the head of the other sprinkler, so that there is a total overlap, so that all the area gets covered. So this is about the sprinkler part. And you have the rain gun irrigation, which I told you, which is also very popular. Of course, you require a higher horsepower for it. And these rain guns also are typically used for fodder grass, for lawns, for dust suppression. And here also the advantages and disadvantages are there. But you will find that again, it is creating artificial rain, and particularly football stadiums and sports stadiums, before the match and just after the thing, you want the dust suppression to happen. That also can be done. And when you're working in artificial, when you're playing in artificial turf, there will be electrostatic force that is developed in the grass. If that has to be neutralized, so generally they will go for irrigation either with these rain guns or with sprinklers. So these are all some of the interventions that are there, and the basically which I started about the micro irrigation, the drip and the sprinkler and rain gun irrigation. Now let us look at the crops. So you name the crop: banana, sugarcane, groundnut, chilies, cotton, vegetables, maize, onion. You name the crop, and today we can use micro irrigation for any of these crops. Let it be papaya, tomatoes, citrus, turmeric, guava, brinjal, mangoes, cucurbits. You name the crop. Even today, drip irrigation on paddy is also very much in the, but of course it is still in the experimental stage. And then it is now like a lot of new crops like what we are seeing, dragon fruit, and so many other high value horticulture, both in open house and greenhouse condition or protected cultivation. Micro irrigation can be advantageously used. So thank you very much for the opportunity given, and thank you for the patience and hearing. With this, I actually close my session, and I'm open to questions from the audience.
Thank you. Thank you, Mr. Vijay Kumar, for a very interesting presentation and talk. It had big details also. It was quite comprehensive. I now request the participants to ask their questions. We'll also be posting the speaker's contact details in the chat window. Now, quickly, we have time for a few questions. Participants, any questions, please? And Mr. Vijay Kumar, can I request you to stop sharing the screen?
Yeah, what should I do? I should just go to
Just
the.
put it on the screen.
Okay.
Yes, thank you.
Okay.
Now over to the participants for questions. Please indicate your willingness by putting on your mic. Any questions? Mr. Suraj Sebastian, any question? Mr. Nayan Mohanty. Of course, the talk was quite comprehensive. I don't know if any questions are going to come up or not. And then Mr. Chidanand, Mr. Manjunath, Mr. Amit Kumar, Mr. Mohardas, and any questions coming up later also after the meeting can also be directed to the speaker whose contact details have
Hello,
been given in the. Yes, Mr.
hello.
Mohardas. Yes,
This is
Mr.
Mrs.
Mohardas.
Mohardas, please. This is Mrs.
Please go
Mohardas,
ahead.
please.
Okay,
Yeah, I
please go
wanted to
ahead.
ask you about I wanted to ask you about drip irrigation in the hilly areas like Darjeeling, because they prefer drip irrigation more. So, what kind of filtration is best suitable for hilly areas like Darjeeling, where there is a mineral content is much more, and the soil is rocky soil?
Yeah, actually, thank you for your question. It's a very good question, actually. Water has always been the challenge, and the impurities that are there in the water definitely pose, for example, in hilly areas and in the areas if you have iron content. And so the first step that you need to do is get your water analyzed, and we'll have to know what is there in the water, and accordingly suitable treatments can be given. But to answer your question, that we can have a basic filter, and if you are going to have a inline drip irrigation system, we could go for a combination of, if the water source is from a tube well, then you can actually go for a basic mesh filter, or you can go for a disc filter. And if you are going to have organic impurities in it, then you will back it up with a filter that is going to be a sand filter. So basically there are different options that are available, and based on the water quality, and we can also go for maintenance. There are some areas, for example, if the electrical conductivity or the pH is very high, in that cases, then we'll have to go for periodic cleaning with the help of dilute acids like phosphoric acid or hydrochloric acid. So these are some options available. If you can specifically send me the water analysis report and also the challenges that you have, we'll definitely. And we also have our people in our Premier Irrigation is headquartered in Calcutta, and we have our people in Darjeeling. We have our entire team in Northeast. I can share you the number of our people. They can actually visit and give you the ideas.
Another thing I want to know whether the source of water, the height of the source of water, that also depends a lot on the water that has to flow through the drip irrigation channels.
Yes, correct. You are right. Drip irrigation operates under pressure. So, like there are a lot of areas where you can take elevation to your advantage. For example, you can have a drum, and you can have the water trickling down into the drum. The drum has to be kept at a minimum height of 3 to 4 meters, say roughly around 10 feet from the ground, and from there you can allow the water to go into the drip lines. So they are called the gravity kits, and in fact, we have lot of kits which we can provide even for small areas. They are portable systems, portable drip system, and they are very economical, and it will operate at a low pressure. So drip irrigation can be operated with even at a very low pressure, like a kitchen garden or a terrace garden. So we have systems which can operate, but you will at least require around 10 feet of height, vertical height, to give you that pressure of half a kg pressure or a little less. Yes.
Okay, thank you so much.
Yeah. Thank
Thank you
you.
so
Thank
much.
you. Thank you for the question and well answered, Mr. Vijay Kumar. Thank you for answering. And now we have no more questions. We see no more questions coming up. It's time to thank the speaker, Mr. S. Vijay Kumar, on behalf of Agriculture Information, for taking his time to speak with us with a very interesting presentation. I now request the organizer of the meeting, Mr. Rajini Jain, to please close the meeting. Thank you.
Thank you. Thank you. Thank you. Thank you very much. Yeah.
You're welcome. You're welcome.
Thank you, sir.
Thank you.
You're welcome.
Yeah.
Thank you, Mr. Lakshmipati. I'd like to thank the speaker, Mr. Vijay Kumar, for taking the time to talk with us. I also like to thank all the participants for their time.